Hi guys, this is lesson 3 on in the series of sets, relations and functions. So this is introduction to graphs, and graphs are very important from competitive exams point of view. Hence this lesson will give you some basics for graphs. So let us begin. First of all, what is a number line? So a number line is a line which represents all the numbers in the universe. From 1.732 to 100 to minus 100, all the numbers will be represented on this horizontal line. So 0 is in the middle. Towards the right are all positive numbers and towards the left are all negative numbers. Like 3.762 will be somewhere between 3 and 4, and this extends to infinity and minus infinity. So R, capital R, represents real numbers. Real numbers are all the numbers on the number line. R positive will indicate positive real numbers, those on the right hand side of 0. Z indicates all integers. Integers are like 1, 2, 3, 100, minus 77. All these are integers. Then Z plus are all positive integers. So R, Z, all these are standard notations which are used in maths, and these will be frequently used in questions as well. Next is a representation of a set. Now, how do you actually represent a set of a number? For example, suppose you want to represent all numbers between 0 to 5, including 0 and 5. So this is how I represent this with square brackets. So a closed set with a square bracket means that the endpoints are inclusive. So this is how we write it. Now some people misinterpret 0 to 5 as this 0, 1, 2, 3, 4, 5, which is wrong, because actually this set contains infinite numbers. That is all the numbers between 2 and 3, between 3 and 4. So hence you can say this represents all the numbers between 0 and 5. The important point to note is that it includes the endpoint as well. Similarly is minus 10 to 10, and this is how you represent it. The dots are filled, which represents this is inclusive of minus 10 and 10. Then is the open set 0 to 5. So these are curved brackets. When you indicate this on a number line, this represents that 0 and 5 are not inclusive. That means all the numbers between 0 and 5, not including 0 and 5. Then is a mixed set, and you can understand this. This will include 0 but not 5. Moving on to the other very important concept, that is of domain and range of a function. I have shown this diagram before as well. You put in value in a function, that value is domain, and what you get out is range. Now this is how you represent it. Now, how do you identify the domain and range of a function, which will make almost 80% of the questions if it comes in your competitive exams? So domain is basically the horizontal span and range is the vertical span. So if you have a graph, the horizontal span will be the domain. So if you have this graph, the horizontal span of this graph is from plus 4 to infinity. So its domain is plus 4 to infinity, including 4. The range of this graph is from 0 to infinity, including 0. So range is the vertical span. So the key here is that just remember the domain is the horizontal span, range is the vertical span. For this question, domain, the horizontal span is from 0 to infinity, including 0. Range is the vertical span, that is from minus infinity to plus infinity, and hence this is the range. Similarly, you can look at this question. We'll take up this concept later in great detail. Next, moving on, so we are transforming from this kind of representation to this. That means your domain will be represented in the x-axis and range is represented on the y-axis. So when you draw a graph, how do you differentiate between a relation and a function? This also I have shown you before in my previous lessons. How do you differentiate between a relation and a function given the graphs? So what you do is you draw a vertical line. If it intersects twice, that means it is a relation. If it intersects only once, that means it is a function. Now why is it so? You can go back to the previous lesson and know. Now moving further, we will be representing different types of functions that we have studied, that is 1, 1 and onto, in graphs. So suppose these two graphs are given to you and you have to identify whether these are 1, 1 or not. So the definition of 1, 1 is that every element of domain has unique image. If you don't understand this, you can again go back to the previous lessons. So x1 over here gives me y1, x2 also gives me y1. That means the image y1 is not unique because there are two elements which are giving me the same image. Hence, you cannot say that this is a 1, 1 function. Moving on, this here x1 gives me y1. So hence here every image will have a unique element in the range. Hence this is a 1, 1 function. The basic funda is you draw a horizontal line. If it intersects twice, that means it is a many 1 function. If it intersects only once, that means it is a 1, 1 function. Moving on to onto function, the definition of onto function is that every element in the codomain has a pre-image in domain. Now the easiest way to identify whether a function is onto or not is to find out whether the codomain and range are equal or not. If they are, then it is an onto function, otherwise not. So the codomain is given in the question, range is what you have to find out. Range, I've told you how do you find out. So you have all the prerequisites, but just you have to apply it. So let us look at this question. The codomain is R. The range of this function is from minus infinity to infinity, which is also R. Hence codomain and range are equal. This becomes an onto function. Let us look at this figure. So the codomain is given here as R. The range is from 0 to infinity. So you can say that range and codomain are not equal because range consists of all the numbers on the real line. Here you don't have negative numbers. So you can say that this is not an onto function. Look, now suppose if I intelligently change the codomain of this function and I define it as R plus. Now what will happen is that my codomain and range becomes equal, and that is what I want to make a function onto. So I have manipulated the codomain. Now it becomes equals to the range, hence this becomes an onto function. So primarily a function can become an onto if you can play with the codomain. So I hope the concepts of 1, 1 and onto functions are clear by using graphs as well. And these are very important topics from your competitive exams point of view. Next, we'll see different types of functions, that are your algebraic functions, polynomial functions, sinusoidal functions, in the next lesson. Thank you.